You can turn on the timer. Maybe. So when a function is defined in continuous at a value, so that's the caveat. That's what you have to watch out for. If it's defined and it's continuous at that value, then the limit can be found analytically just by plugging it in. So the limit as x approaches a of f of x is equal to f of a provided f of x is continuous at x equals a. So when we're going to have problems is like if there's a jump in the graph or an asymptote there, or if there's a hole in the graph at that point, that's where we're going to have problems. But other than that, it's just plugging and chugging, which is like awesome because we need some easy things, right? Especially this year. So we are going to find each of these analytically, which just means algebraically. We're going to plug in numbers. So this first one, I'll do easy with you. We have 1/2 times 3 squared minus 2 times 3 plus 3. 4.5. Close. So this is 1/2 times 9, so 9/2 minus 6 plus 3. I think it's 3/2. That's what I got. Because 6 is 12 over 2, and 3 is 6 over 2. So 9 minus 12 is negative 3, plus 6 is positive 3 over 2. And it's just arithmetic. And the way all of your tests will go from here on out is you'll have like I think I told you this already. But you'll have a calculator test, and then you'll have a non-calculator test, or vice versa. I'll let you know before test. So sometimes you'll be given a calculator, and sometimes you won't, and that's because that's the way the AP test is set up, provided we get to have a normal AP test. Who knows? So I'm just going with what it usually is until I know different. Okay, so you just go ahead and do B and C. Do B and C. We'll do D together. Okay, what about B? What do you think? Anybody?
17.
Yep. Which that's 5 times 3 plus 2 over 2 times 3 minus 3. And if you work out each one of those, that's where we get 17 over 3. What about C? 1/3 is right. Again, square root of 2 plus 2. So that's square root of 4, which is 2, minus 1, that's 1, and then over 2 plus 1, which is 3. And then we have, dun dun dun, the trig. Yes, which is why I was like, we have to do trig. I'm sorry, y'all. In pre-cal, we got to do trig because it shows up all the time in calculus. And in calculus, it's always going to be radians because degrees are not real numbers. So radians are. And we know that everything in calculus has to do with real numbers. No complex numbers, but also no degrees. So this is the sine of 2 times pi over 2. I'm just plugging that in. So it's a sine of pi.
That doesn't sound cute at all.
No. Well, it makes me hungry. Does anybody remember? No calculator. No, I'm just kidding. Does anybody remember what the sine of pi is? How we figured that out? I'm going to add a page here somewhere. Nobody remembers. I did a terrible job teaching you.
Well, we were missing, half of it.
Well, yeah, but you were here for that part, actually.
Oh, the circle thing?
Yeah!
Oh, yeah, I don't remember what it is, but I do remember this.
So, at this point, this is a unit circle.
Yeah.
Yeah.
Crazy numbers on
And in a unit circle, we have, this is 1, 0, because it's a unit.
0?
Ooh, yes, it is 0. This point, pretend that's a circle, is 0, 1. This point, negative 1, 0. And this point is 0, negative 1. So at here, this was 0 radians. Then we had pi over 2 radians, which was the same as 90. Then pi. Then 3 pi over 2. And 2 pi, and so on. You keep adding pi over 2. So, the x-coordinate on a unit circle is the sine. No, got that backwards. The y-coordinate is the sine, sorry. And the x-coordinate is the cosine. Just on a unit circle. So we had the sine of pi. So that's over here. Sine.
0?
Yep. Sine is the y-coordinate. So it is the 0. Which is what you told me. Alright. Ooh, lovely. Ooh, some more trig. So we have the cosine of 2 pi over 3 over 2 pi over 3. Now I will venture to guess that most of us are like, yeah, I don't remember. Especially since we didn't remember the unit circle, which is okay. We're reviewing. So first off, we can change 2 pi over 3 into radians, or degrees. So it's something that we're familiar with. Does anybody remember?
270? 180.
Yeah, 180 over pi, and it might be 270. Let's see. Pi's cancel. 3 goes into 3 goes into that 60. It's 120. I canceled out the pi's, and then I cross-canceled. The 3 goes into 180 60 times. That's where that came from. Did I lose anybody? All right. So then 120, we're going to draw it out. Remember, if it's in standard position, starts here, and I rotate 120 degrees this way. Because remember, this one's 90 up here, so it's a little bit more. And it gives us a reference triangle. What's the reference angle going to be? 60, yes.